All right, so looking at solo attempt number 3 here, comparing some birds to some land animals and the different speeds that they can achieve. So let's start with the birds here. And I found my median, worked my way to the center, and I ended up at 100 and 95. So I had to decide what was exactly between those. So now let's go ahead and find our quartiles. Upper quartile, I guess I can do that first. So 1 and 1, 1 and 1, and what's between 105 and 106? 105.5, so there's our upper quartile. There's our maximum. Let's find our lower quartile. 1 and 1 here. And what's between 80 and 72? It's kind of like saying what's exactly between 10 and 2, if you can kind of see my way of thinking there. But of course, if you don't know, and if you have trouble figuring that out intuitively, you can always take 80 plus 72 divided by 2. So this would end up being 152 divided by 2, which would be, I believe, 77. No, that's not right. 76, I think, is a better number. And we can make sure of that. I'm actually not, I'm pretty certain of that. I'm going to roll with it. 76, I'm pretty confident that's our lower quartile. So lower quartile, upper quartile, maximum, and our minimum. Good, let's go ahead and get our land animals done as well. So if we look over here, I'll do the upper quartile first. So down and, let's see, 2. 3, 4. Oh, this is easy. What's between 50 and 50? But 50. There's our upper quartile. Lower quartile, keep going down here. So it looks like I'm going to end up between 35 and 30. That's going to be 32.5. That's our lower quartile. Maximum and minimum. So not too hard to get these made. Let's start with our birds here. And for our birds, our lower quartile was 76, so roughly here. And for our upper quartile, it was 105.5, so it's right about here. Whoops, didn't need to go that deep down there with my box. Then my median is about 97.5, almost to 100. But we've got some extremes with the birds. We have the slowest bird only, let's see, 50 to 75. That means I have 55, 60, 65, 70. Okay, so 60 is about right here. The birds are really, they're all pretty much right in this area. They're not too spread out. But then we have one extreme. The Persian falcon is very, very fast. Is going to end up way at the far end of the dot plot, representing an outlier. Let's go ahead and take care of our... Oh, man, I forgot to title these differently. This one should say animals. Land animals. Got to title that properly, and let's get this made for our land animals. There's a few more slower land animals here. Our lower quartile was 32.5. So remember what our number line looks like here. We have 30, 35, 40, 45. So where's 32.5 in all this? Well, here's 25, here's 30. 32.5 looks like it's right around here. And then let's go ahead and make our upper quartile, which is 50. That one's pretty easy. That's right here. So as we can see, very, very bunched up here. And then we can put our median line in here somewhere. I know that I have 30, 35, 40, so 43.5 is going to be somewhere just to the right of that. So the box is not only lower, not only further left, but it's also very, very small. Most animals are between, for their maximum speed at least, they're between this 30 and 50 mark, so not too far apart. And then we have our slowest animals. Let's go ahead and mark that down here. 5, 10, 15, 20, 25. So where would 9 be? Very close to 10. 5, 10. There we go. And then our maximum speed animal, the cheetah, still doesn't get anywhere close to the bird's dot plot. So as we can see, there's not much overlap in the speeds of these two animals. And on the very next page, we can actually start to analyze these and try to make a statement about what we see with birds and their maximum speeds compared to the maximum speeds of land animals. Remember, this is the fastest they can travel. So it's their top speed, not what's average, but what's their top speed. So let's take a look here. What are the minimum and maximum values for each animal? Well, the fastest bird is 242 miles per hour, and the fastest land animal is 75 miles per hour. The slowest bird ended up being still 60 miles per hour. So that's not much slower than the fastest animal. And the slowest land animal is about 9. And now it is 9 miles per hour. So that's what we can say about the fastest and the slowest. what does the interquartile area tell you about the data? Remember, that is our box. Interquartile area is the box on our box plot. That's the middle 50%. So we can say most birds, 50% of them, if we look back, they're between this marking right here, which was 76, and this right here, which is 105.5, or that's about equal to 106. So we can say most birds, 50% of them, are between 76 and 106, are between 76 and 106 miles per hour. Meanwhile, most land animals are, we might want to say are only, because they're going to be much slower. And remember, our land animals are only between about 33, right? I rounded the 32.5. They're between about 33 and 50 miles per hour. So between 33 and 50 miles per hour. What can we say about the center of the data? Typically, most birds fly around, we said about 97.5 miles per hour. And most land animals are at about 44. About, because I'm going to round that 43 number, 44 miles per hour. Where did I get these two numbers? Notice that I said typically. This typical value is our median. And that's what I'm saying here, right? Typically, most birds fly at 97.5 miles per hour, and most land animals are about 44 miles per hour. Because this is the median, which represents a typical or normal value. So now let's actually start to think about some assertions we might make that helps us think. We want to try to compare these two sets of animals. That's what we're going to use our assertions to do. So as I look at this, I could say typically most land animals have a slower maximum speed than most birds. So I might start with that. Therefore, typically, most land animals have a slower maximum speed than birds. But let's try to think of some other things that we can say. We do know from our dot plot, the scales are the same. There is a little bit of overlap. And if you look at this, there are a couple animals that are just as fast as the birds. So I might say something like this. Another assertion I might make is, therefore, even though even though birds, maybe I'll start with that, even though birds typically have faster maximum speeds, there are a few extreme animal values, or extreme land animal values, that are faster than birds. So why did I do two assertions here? That's just to kind of open it up and to show you there's different things you can argue. All of these facts, in fact, we have all kinds of facts up here. This is a fact. Question 2 is a fact. Question 3 is a fact. Question 4 is a fact. These are all facts leading us to assertions. What we need to know, though, is that there's not one right answer. Both of these are good assertions that you could have written when you're analyzing this type of data. Both of these are just as good as long as you have all of this evidence up here to back it up. So for your last thing you're going to do, you're going to take solo attempt number 4, and you're actually going to take the measures of center of these 3 classes and some tests they took. It was a 20-question quiz. You're going to put them into box plots, and you're going to write about 4 facts about the data that you see, and 4 or 5 facts about the data that you see. Remember, you can think about the minimum, maximum values. You can use these guiding questions to help you think about what kind of facts you might write. And then, of course, at the very bottom, only write 1 or 2 assertions in the left box. This is the my answer space. And then, of course, we'll do a class answer on the right.